Good afternoon, everyone. Sorry I couldn't be there with you today. Today we're going to be looking at reviewing the expanding and factoring that we've looked at last week. So we looked at a couple different types of expanding and a few different types of factoring, and we're going to just be putting that all together today and deciding when do we use each of those different types. So we're going to review them first in this short little lesson, and then you're going to be given a practice assignment where you have to decide which one do you use when. So let's quickly review first. We have two different types of expanding that we looked at. The first one was what we're going to call simple expanding. That's when there's a single number or a variable in front of the bracket. And all we did was you multiply that value by everything inside the bracket and then collected any like terms if there were any like terms to collect. So let's take a look at the example. It asks us to expand and simplify. We see that there is this one single term in front of our bracket, so that means we just take that term and multiply it by everything inside the bracket. So we have to multiply 2x by the 3x, and then also multiply the 2x by the negative 1. So let's expand this out. 2x multiplied by the 3x. We do the numbers first. 2 times 3, that gives us a 6. Then we do the variables. X times x gives us an x squared. And then we have to do the 2x multiplied by negative 1. So 2x multiplied by negative 1 is just minus 2x. Then we look, is there any like terms? We have an x squared and an x. Because the variables are slightly different, then no, we don't. So this is our final answer. Please make sure everyone has this in their notes before you move on to the next one. I'm going to move on to the next slide, so pause the video if needed. The next type of expanding that we looked at was expanding binomials. This is when there are two brackets that are multiplied by each other. So something that looks like this, or we have some sort of number plus another number. And then in the second bracket, we have another two pieces inside those brackets. When we have two brackets multiplied by each other like that, that's when we used our FOIL. And then we collected any like terms. So remember, FOIL is we do the firsts, the outsides, the insides, and then the last. So we have 4 different terms in that point. Then we collect the 2 middle terms because they're always the 2 that are the like terms. And then our final answer should always be in this format where we have 3 different pieces. We have some sort of number, x squared, plus another number x, plus a number all by itself. So let's take a look at our example here. Again, we're asked to expand and simplify, so notice the instructions are still exactly the same, but because we have the 2 separate brackets, that's when we know we have to use our FOIL. So remember with our FOIL, our firsts, is we take the number that's in the first spot in the first bracket, multiplied by the other number that's also in the first spot in the second bracket. So let's just do this piece by piece. So we have 2x multiplied by x, so that gives us a 2x squared. Then we do our outside, so that was our first. Then we do our outside, and our outside is the terms that are sitting on the outermost piece of the bracket, so that is the 2x here, and the negative 4 here at the end. So let's do that multiplying piece. 2x multiplied by a negative 4x. So we have our numbers. So 2 times by a negative 4 will give us a negative 8. And then we have that x. So we have negative 8x. Then we'll do our inside. And our inside are the ones that are the innermost piece of the bracket. So this 1 here is in the middle, and this x here is in the middle. So we multiply those. And when we multiply 1 by x, we just get a plus 1x. And our last Those are the terms that come last in our bracket, so the 1 here and the -4 here. And when we multiply, we do +1 multiplied by -4. That just gives us a -4. So that was the expanding part using our FOIL. Now we have to simplify. And remember, it's always the two terms in the middle that are the like terms whenever we FOIL. So those are the two terms that we're going to simplify together. So we still have our 2x squared out front. Now we can put together the -8x plus a 1x. So that gives us a that gives us a -7x. And then the -4, it doesn't have a like term, so it just carries down. So now that we've put all like terms together and we have our 3 pieces in our final answer, we are finished. So just remember, you only FOIL when you have 2 brackets that are multiplied by each other, meaning that there's 2 pieces in each bracket, and our final answer should always have the 3 terms that look like this, an x squared, an x, and then a number without a variable. Again, please make sure everyone has this down. Pause the video at this point because I'm going to move to the next slide. So that was looking at the 2 different types of expanding that we looked at last week. We also looked at 3 different kinds of factoring. The first kind of factoring that we looked at was the common factoring. That was when we found out what the greatest common factor was, which we can short form to GCF. Then when we were asked a common factor, we put that greatest common factor in front of the bracket, and then inside the bracket, we divided each of the original terms by our greatest common factor, and then we simplified it out to get our final answer. So first, in this example, we need to look at what is our greatest common factor. So first, look at the numbers. What can we divide out of both a 3 and a 12? And you should say that the greatest common factor is 3. We can divide the 3 by the 3, and we can divide the 12 by the 3. Then we want to look and see, is there also a variable that we could take out? And we see that there's 2 x's here because it's an x squared, and 1 x here, so we could also factor out an x. So we're going to common factor out a 3x. So first we're just labeling that our greatest common factor is 3x. Then in our answer, we put that greatest common factor out front, and then we put brackets. Then we're going to do 3x squared divided by 3. So again, you can do it in pieces. 3 divided by 3, that just gives us a 1. And x squared divided by x, that just leaves us with an x. Then do it with a 12. So 12 divided by 3, that gives us a positive 4. And x divided by x, because there's only one x and we took that x out front, the 4 no longer gets an x, so it's by itself now. So here's our final answer. We common factored out a 3x, so it sat in front of the brackets, and then we divided everything inside the brackets by that 3x, so it's now just x plus 4. And that's our final answer. With common factoring, we common factor when there's typically 2 terms. Sometimes we can do it with 3 terms. It's something that we usually look for at the beginning. Is there anything that we can pull out front? So I'm going to move on to the next slide here. The next type of factoring that we looked at was trinomial factoring. Trinomial factoring was when there was 3 terms, and it was typically always in this form here. We'd have an x squared, some number with the x, and then some number by itself at the end. Remember, when we're doing this trinomial factoring, whenever there's 3 terms, we use our MAN statement. So the M is that we have to multiply to C, which is always the last number at the end. We have to add to B, where B is always that number that's in the middle with the x. And then we have to come up with N. We have to come up with 2 numbers that multiply to the C, but also add to the b value. Couple different patterns that are good for us to remember when we're trying to come up with the numbers because it can help you come up with those numbers is that if the multiply number is positive and the add number is positive, then both of our numbers must also be positive. If our multiply number is positive but our add number is negative, then it means that both of our numbers must be negative. If our multiply number is positive, but our add number is positive, or sorry, if our multiply number is negative, but our add number is positive, then it means we must have one number that's negative and one number that's positive. And because our add value is positive, that means the smaller number is the one that needs to be the negative number. The last pattern is if the multiply number is negative, but the add number is also negative, we know for sure that one number must be positive and one number must be negative. But because the add number is negative, that means the bigger number has to be negative this time. So make sure you have these patterns out and ready when you're trinomial factoring because they'll help you out really quickly to help you come up with some of those numbers. So let's take a look at our example here. We have three separate pieces. We have our x squared, a negative 5x, and the plus 4. So we know we have to do our trinomial factoring. Let's pull out our key pieces. So our m value is the 1 at the end without an x, so that's the 4. We have to multiply to 4. Our add value comes from the middle, so then we have to add to a negative 5. And now we need to come up with our two numbers. So a couple different things. We look and see that our multiply number is positive. So it's positive. Our add number is negative. So we know that both of our numbers must be negative. So we'll look at our patterns here. Multiply is positive, our add's negative, so both numbers must be negative. Both numbers must be negative. The other thing that we can look at that can help us try and come up with our two numbers is look at the multiply number and list out what are all the different things that multiply to that number. So go through what are the different numbers that multiply to 4. Well, we can do 1 times 4, that gives us 4. And we can do 2 times by 2, that also gives us 4. So we know our only options to choose from for our numbers either has to be 1 and 4 or 2 and 2. Then we know that both of our numbers have to be negative from our original pattern. So let's throw those negatives into those numbers. It has to be a negative 1 and negative 4 or a negative 2 and negative 2. And then we look at and think about which one is going to add to our negative 5. So if we do negative 1 plus a negative 4, that gives us negative 5. If we did negative 2 and negative 2, that gives us a negative 4, so that doesn't work. So we can cross out the negative 2, negative 2. We know it doesn't work. We know that negative 1, negative 4 works because it multiplies to a positive 4 and adds to negative 5. So we know our two numbers are negative 1 and negative 4. Remember, once you have your two numbers here, all you need to do when doing trinomial factoring for your final answer is to then throw those two numbers into your brackets with your x's. So remember, our brackets always start with x, and then we put in our numbers. So we have x minus 1. And in our second bracket, again, it starts with an x, so we have x minus 4. And that is our final answer for our trinomial factoring. When you're trinomial factoring, your final answer will always be looking like this, where you have your two separate brackets and then x in the front of both of those brackets. Again, please make sure that everyone has this in their notes. I'm going to move on to the next slide. The last type of factoring that we looked at was difference of squares factoring. This is when we have two terms, only ever when we have two terms. And the other key feature is that we have to have a negative in between those two terms. If we don't have a negative in between those two terms and there's nothing we can common factor out, then there's no way that we can factor it, and we say not able to factor, and we list why we're unable to factor that. The other piece of difference of squares is that we square root both terms that were given. When we square root both terms, they must give us an integer when we square root. If they don't, then again, we can't use our difference of squares. So the key pattern with difference of squares is that in our brackets, the square root of the first term of our question, it goes in the first spot of our brackets, and the square root of the second term, it goes in the second spot in our brackets. And the only difference between our two brackets is that one bracket has a plus in the middle and one bracket has a minus in the middle. Let's take a look at our example here. First, let's go through our list. We have two terms, and we look, yes, there is a negative in between them, so it's likely that we can do difference of squares. Now let's square root our two terms. So we're going to square root the 16x squared and figure out what that is. So the square root of 16, when you type that in your calculator, that's a 4. And the square root of an x squared is just x. So the square root of 16x squared is equal to 4x. Now we need to square root our second term. And our second term is the 25, so square root of 25. And the square root of 25, when you type that into your calculator, is a 5. So then in our final answer with our brackets here, the square root of our first term is a 4x. So that goes in the first part of both of our brackets. Then the square root of our second term, the square root of 25, that's a 5. So that goes in the second part of each of our brackets here. And then in each of our brackets, one bracket gets a plus and one bracket gets a minus. And that is it for our difference of squares factoring. So that's our final answer here. And again, it looks like we have our two separate brackets. The only difference is that one gets a plus and one gets a minus. So now we've reviewed the two different types of expanding and the three different types of factoring. On the practice assignment that you're going to be working on, so I'm just going to move on to the next slide, so please pause it if there's still people writing. The practice assignment that you're going to be working on, I break it up between expanding and factoring, but I don't tell you which type of expanding or which type of factoring that you need to use. So this is where you need to look over all these different key summaries that we just did in this lesson and decide which one to apply. So please be working on that practice assignment, and it will be collected so I can take a look and see how well you were able to do. So please use your time wisely and ask for help when you need it. Otherwise, have a great day, and I'll see you all tomorrow.